Chemically, aluminum has an enormous affinity for oxygen. This results in a thin film of aluminum oxide being formed on the surface of aluminum when it's exposed to air or other oxidizing atmospheres. The aluminum oxide film is inert and protects the underlying metal from further reaction. Finely divided forms of aluminum, such as atomized powders and flakes, present a large surface area for reaction and are prone to rapid oxidation. When an aluminum particle is heated to a sufficiently high temperature, known as the ignition temperature, the mass of the particle is so small that the entire particle may oxidize almost instantly. Thus, a pile of such particles may burn. Since flake particles have a much greater surface area per unit mass than do atomized or granular particles, they will ignite more readily and burn faster than atomized or granular particles. Fine particles of aluminum powder, like many organic powders such as flour, sugar, wood dust, coal dust, and plastic resins, are easily dispersed in air, where their low mass allows them to remain suspended or float in the air for extended periods of time. These suspended particles will burn, similarly to particles in a pile when the ignition temperature is reached. Additionally, when dispersed in the proper proportion in air, the particles are intimately mixed with the oxygen in the air, allowing the burning to extend from one particle to another with such rapidity that a violent explosion can occur. Laboratory tests have established the proportions of aluminum powder required for a dust-air explosion. The concentration of aluminum powder required for an explosion varies through a wide range and depends on the article's size and form. In general, very little aluminum powder is required for an explosion to occur. Tests have shown that aluminum powder in the form of a dust cloud will ignite with as little as 6% oxygen present, with the balance of the atmosphere being nitrogen. Very little energy is required to ignite mixtures of aluminum powder and air. A static electrical discharge will produce a spark that raises the temperature of the aluminum powder articles in its vicinity above the ignition temperature, resulting in an explosion. Conventional electric equipment such as switches, junction boxes, electric motor commutators, broken light bulbs, loose electrical connections, even a metal-to-metal impact, or any spark-producing event can set off an explosion where aluminum powder is suspended in air. Very hot surfaces, such as an engine manifold or continued metal-to-metal rubbing, such as in a dry sleeve bearing, can generate enough heat to initiate an aluminum powder air explosion.